good. So yeah, it was a long break. So how was you guys' summer break? How did it go?
Yeah, it went well. Actually, it was
Uh,
a nice and exciting vacation. Yes. What about you?
yeah, that's very good to hear. My school started to around 2 weeks ago, but we still had some Labor Day breaks, so that was really good. And yeah,
All right, all right. That's nice. Good to hear too. Yeah, so we are back again to school. Yeah,
yeah,
so the students are also ready for the lesson, so we can start from now. Yeah,
okay,
since we are far behind with the time. Yeah.
yeah. I
All
don't
right.
think we are too behind. But yeah, it's fine. We do have like a fixed schedule, and um, there are some topics I wanted to cover over the fall and
Yeah.
into spring too. So,
Yes. This time I think there will be only one holiday or so. So
oh,
with the
okay.
time, with the Fridays, I think if there is any changes, we will alert you or we'll let you know in advance.
Okay, yeah, please let me know and I can adjust the schedule accordingly.
Sure. All right.
Yeah, so
Okay.
yeah,
So
let's start with the lecture. If that's okay now.
okay. Right.
Okay. So today, everybody, we will be learning about atoms and molecules and the properties of elements. So yeah, today's topic is on atoms and molecules, and we will also look at what's called the periodic table. So do you guys see the periodic table on the bottom? I think you guys might have seen this before, but today we will be learning more about it. Like, what does this say about certain elements? So that will be today's topic. So to introduce you guys to atoms and molecules, what they are, we will start by watching this video. So it's a fun little video that I prepared. So here is the video. I hope you guys enjoy it. Yeah, I hope you liked the video. It was about atoms and molecules, and we learned about what an atom is. So, an atom is the smallest unit of matter that has the chemical identity of an element. So, it's the smallest possible thing of any matter. And atoms consists of three main subatomic particles like protons, neutrons, and electrons. And atoms combine to form molecules. So more than one atom is called a molecule. And it makes up all substances in the universe. So everything is made up of atoms. And some things are made up of molecules, which are just combinations of atoms. So let's look closely at what an atom is. So this is the structure of an atom in colored format. So again, an atom is the basic building block of any matter, and it cannot be divided any further. So this blue ball in the middle, can you guys see the blue ball in the middle? That is the proton, since it has the positive charge. Protons have positive charge. And you can see something other red balls in the middle. This is called the nucleus. And this other red ball is called the neutron. So protons and neutrons make up this nucleus at the center. And you can see electrons orbiting around the atom, and this one has a negative charge. So electrons, you can see here, orbits the nucleus, and the nucleus has protons and neutrons. So the number of protons, because it is positive, and it also has the same number of electrons. So this is important. Protons and neutrons number are the same. So the net charge would be 0. An atom does not have a charge. Let's look at this review quiz. So this is a quick question that you guys can answer. So an atom of an element has a neutral charge because. So what do you guys think the answer is for this question? Is it A, protons and electrons are the same particles? So who here thinks it's A for this question? You can just raise your hand. I don't think I see anyone. What about B? Proton number and electron number are the same. So who thinks it's B? Is B the answer? You can just raise your hand if you think B is the answer. So here we can see that I've written here, it's a little hint, that the number of protons equals the number of electrons. So the atom is neutral. So always remember that the number of protons equals a positive charge, and the number of electrons equals the negative charge. So that's why the answer must be B, right? Because proton number and electron numbers are equal, the charge remains neutral. So neutral charge means zero, zero charge. So let's say an atom has um 5 protons. So how many electrons should this atom have? It should also have 5 electrons, right? Because here this is positive 5 protons and then negative 5 electrons. And the charge would equal to 0, right? This will equal to 0. So that's why the proton number and the electron number must be the same. Same in the atom to make a neutral charge. So that is the answer. Now let's look at another question. Let's see if you guys can answer this one. The two main particles of a nucleus of an atom are. So what are the two main particles in the nucleus? Is it A, neutrons and protons? Is it B, neutrons and electrons? Is it C, shells and neutrons? Or D, electrons and protons? So who thinks A? You can raise your hand if you think it's A. Yeah, I think I see some people raising their hands. Yes, the answer is A. That's right. Um, Inside the nucleus, there are protons and neutrons. And let's look at question 3 here. So an atom has 20 nucleons and 9 protons. So what is the neutron number? So a nucleon is the proton number plus the neutron number. So how many neutrons it will have is just 20 minus 9, which is 11, right? So C is the answer for number 3. So does everyone understand so far? Is everything clear for everyone? Oops, I don't think I can hear you very well. Let's see. But if you come across a question, please come up and ask. Um, and I will be happy to answer any questions. Any? But let's continue with an example of a carbon atom. So this is a carbon atom, and you can see these numbers. It says 6 and 12. So 6 over here is the number of protons and electrons. A proton. And it is also the number of electrons. So 6 is the number of protons and the number of electrons. But 12 here, let's see, 12, that's the number of nucleons or the mass. It's, so you can simply think of 12 as the number of nucleons, but this is measured in atomic mass units. So this is the mass of an atom. So carbon atom has 6 protons, 6 electrons, and 6 neutrons because the total nucleon is 12. 6 plus 6 should equal 12. So that was an example with a carbon atom. I can resume back in the proton number and the electron number. So yeah, like I said, 6 is the proton number and electron number, and 12 is the atomic mass, which also equals the total nucleons. So if carbon has 6 protons, so 1, 2, 3, 4, 5, 6, and the mass is 12, 12 minus 6 equals 6, right? So there should be 6 neutrons. That is how you find the number of protons, electrons, and neutrons. So proton number always equals the electron numbers, and you subtract the proton number from the atomic mass to get the neutron number. So that was an example with a carbon atom. And let's move on to molecules. So what is a molecule? A molecule is a group of 2 or more atoms that are chemically bonded together. So these atoms can be of the same element, like oxygen gas. You see O2, it's made up of oxygen plus another oxygen, which goes to O2. Or it can be different elements, like water, which is H2O. You can see there are two hydrogens and one oxygen. So this is actually O2 plus hydrogen gas. Goes to 2H2O. So you can see how it involves two different types of elements. It has hydrogen and oxygen. And molecules have their own physical and chemical properties. They have their different properties and they are also electronically neutral charged. There are some molecules where there are charges attached, but most of these are formed and are not really natural. So we talked about oxygen gas, O2. It has two oxygen atoms. It's made up of same elements. We talked about water molecules, H2O. It consists of two hydrogen atoms and one oxygen atom. And these are different elements. So let's look at this question. So maybe you can answer this one by yourself. So how many atoms are in H2O2? It's hydrogen peroxide. So how many atoms are in H2O2? So there will be four, right? Because there are two hydrogen atoms and two oxygen atoms. So there are a total of four atoms. Now that we have learned more about atoms and molecules, let's look at some properties of elements. And this video will also cover um, more of periodic table and also some fun properties that some elements can have according to the periodic table. So let's look at this video. It's another fun one, so I hope you guys like it. Yeah, so that was the video about properties of elements. And this video was more focused on what periodic table tells us about certain elements. So to recap, elements. So what is an element? An element is a pure substance made up of only one kind of atom. So we've talked about oxygen gas, which is just made out of oxygen. It's O2. And hydrogen gas, H2, is just made up of hydrogen atoms. And gold and carbon, these are some examples of elements. And there are 118 known elements. And elements are listed in the periodic table by increasing atomic number, which remember always equals proton numbers, which always equals electron numbers. So that is the pattern of a periodic table. We've talked about this before, seen in our other slide, but this again is one of the blanks in the periodic table. This is carbon specifically. We have talked about the number on top equaling the atomic number, which equals the number of proton, which equals the number of electrons. In the middle is C. This stands for carbon, is the chemical symbol. And at the bottom, there is the atomic mass, which we already talked about, was the number of nucleons. So for carbon, it is 12. So nucleon is, again, proton plus neutrons. So carbon has 6 protons. So carbon should also have 6 neutrons. That is how we can tell the amount of protons, electrons, and neutrons a certain element has. So let's look at this periodic table more broadly. So you can see that many of these are categorized into groups. So all these different colors tell us that they are in different groups. And again, each groups have their own properties. They can be reactive, not reactive, or they can be metals, non-metals, or metalloids, like the video talked about. Let's look at this question. So the periodic table is an arrangement of elements according to increasing. So we've already talked about this. Is it increasing atomic number? Is it increasing mass number? Is it increasing nucleon number? Or is it increasing neutron number? So it should be increasing the atomic number, right? So if we can see here on the slide in the periodic table, you can see the numbers on the top left of each box. There's 1, here it says 2, 3, 4, 5, 6, and so on. The numbers are increasing on the top. And that is the atomic number. So that is how the periodic table is arranged. So now we get into these different general groups. And these simpler groups can be divided into 3 main parts. Those are metal, non-metal, and semi-metal or metalloid. You can see here that this periodic table is colored by these different properties. Metal is this purple shade, non-metal is this gold shade, and metalloid is colored in green over here. You don't need to memorize all the elements that are metal or non-metal or metalloids, but it's important to know some properties that each element has according to whether it's a metal. And it's also important to know that metals are usually on the left side on the periodic table, as you have noticed. And nonmetals are more on the right side of the periodic table. And metalloids are somewhere in between. The only exception to this is hydrogen, which is non-metal. But metal is found on the left and center of the periodic table, like I've said. Some properties. It is shiny, called lustrous. Metals are good conductors of heat and electricity. Metals are malleable. That means that it can be shaped easily. It can be hammered into other shapes easily. And they're ductile, meaning they can be stretched. So metals can be shaped in many different ways. You can squish it and you can stretch it. And usually solid at the room temperature, well, except mercury, which is a liquid. And metals tend to lose electrons in reactions. And I will get to that in just a bit, why they lose electrons in reactions. But let's look at nonmetals first. So nonmetals are elements that do not have the properties of a metal. Like we can see here, nonmetals are on the right side of the periodic table. It's on the right side. Again, like I mentioned, except hydrogen, which is on the left. It's an exception. Nonmetals are very poor conductors. That means they do not pass through heat and electricity. They are not shiny. You can see the picture of sulfur and carbon. These are not really shiny like metals. And they are brittle, which means that they break easily. They cannot be shaped into other shapes. And when you try to do that, it just breaks. Nonmetals can be solid, liquid, or gas at room temperature, and they can tend to gain electrons in reactions. And again, I'll get to that in just a little bit because it's a different topic. But let's finally talk about metalloids, last group of this categorization. Metalloids, or semimetals, have properties of both metals and nonmetals. For example, there are silicon, boron, arsenic, germanium, and other stuff like you can see here. There's also other elements. There are a total of 1, 2, 3, 4, 5, 6, 7 metalloids. And they're semiconductors, which means that they conduct electricity better than nonmetals, but not as well as metals. So it's kind of in between. And most metalloids are used in computers, like you're using right now. Your computers use most likely silicon for their microchips, and also in smartphones and other electronic devices, since they can control these electrical impulses very well. And now let's get into a little bit about electron shells. So, although the video did not really mention this, it is important to know that electrons orbit in the nucleus layer called shells. And each shell can hold a certain maximum number of electrons. So the first shell can hold up to 2 electrons, second shell 8, and third shell 18 electrons, and so on. And the outermost shell is called the valence shell, and it plays a key role in reactions, as we will learn later. But here is the general sort of shape of electrons and how they are covered in shells. So a stable atom has 2 inside. You can see 2 electrons in the first shell. This is the first shell. Let me color this differently. This is the first shell. This is the second shell. And this is the third shell. This is the third shell. And you can see 2 electrons in the first shell. 1, 2, 3, 4, 5, 6, 7, 8 in the second shell. So that makes a total of 10 electrons. And then there are also 8 in the third shell. So there are a total of 18 electrons when there are 3 shells. And it is important to note that many atoms want to have 8 electrons in the third shell, and that is called like a noble gas, or what's at the most stable form. So this can be a little confusing, but it's okay if you don't get it on the first try. The reason I said why metals lose electrons and non-metals gain electrons is because they want to have 8 electrons on their outermost shell. So always remember 8 electrons equals stable. So every atom wants to have 8 electrons on their valence shell. But let's look at sodium, for example, here, sodium. You can see it has 11 electrons. And do you see this extra electron on the third shell? This one? Sodium doesn't want that. Sodium wants this electron out. Why? Because sodium will have 8 electrons on the valence shell if it knocks off this one electron. It's bothering sodium, so it wants to lose this electron. That's why, in many reactions, sodium tends to lose 1 electrons to become stable. So when a sodium loses an electron, it becomes Na plus. It's called an ion. So this is a sodium ion. And ions are formed only when there is another atom that wants to lose an electron. So if we have chlorine, we have a chlorine atom. Let's look at what bothers chlorine. So chlorine has 1, 2, 3, 4, 5, 6, 7 electrons, right? Does chlorine want 7 electrons on its shell? No, right? It wants 8 electrons. So it wants to gain an electron to have 1, 2, 3, 4, 5, 6, 7, 8. Now sodium is happy. Before, sodium was not happy because it only had 7. Chlorine, sorry. Chlorine had only 7, so it was not happy. But since chlorine gained an electron, now it has 8. And this forms chlorine ion, Cl minus. This is called a chlorine ion. So to make it stable, we want 2-8-8 formation. This means having 2 electrons in the first shell, 8 electron on the second shell, or you can go beyond, having 8 electrons in the third shell. So this can be a little complicated. Did everyone understand the formation of ions? Does anyone have any questions for this? So maybe you might ask why I put the plus symbol here, but a minus symbol here. So why does sodium have a positive ion, but chlorine has negative ion? See, the difference is sodium lost an electron. So that's why it has a positive charge. It has more protons than electrons. But chlorine, it gained an electron. So it has more electrons than protons. So it'll have a negative charge, right? And that's why sodium and chlorine combined form NaCl. Sodium gives an electron to chlorine over here. And now both sodium and chlorine are happy. They have 8 electrons on both of their shells. Yeah, does anyone have any other questions about ions and electron shells? If you have questions, always feel free to come up and ask. Um, but otherwise, I will continue. Oh, and notice that sodium, since it loses electron, what is it? Sodium is over here. It's a metal. So metals, like I've said, tends to lose electrons. And nonmetals on the right, like chlorine right here, tends to gain electrons. That's why I said here. Metals loses electrons, nonmetals gain electrons. And finally, let's talk about ions, the type of ions. Like I've said, positive means losing electrons. If it has a negative charge, it means the gain of electrons. Positive ions are called cations, and negative ions are called anions. So those are just the names of the ions. So we've already talked about this. We talked about losing and gaining electrons. So this should be pretty clear. But recapping, again, sodium lost an electron, so it has positive one charge. It's a cation. Sodium is a cation when it forms an ion. Fluorine, on the other hand, it needs to lose, it needs to gain an electron, one electron here. Once it gains it, it has a negative charge. So it's an anion. C. For fluorine, it has 1, 2, and 1, 2, 3, 4, 5, 6, 7. It has a 2-7 shell structure. And fluorine doesn't want that. No atom wants a 2-7 structure. They want 2-8 or 2-8-8. So always remember, atoms want 2-8 or 2-8-8 structure. Since it has 2-7, we need to add an electron to make a 2-8. This forms a fluoride ion, F minus. And again, we can easily see this on the periodic table. On the left side, it tends to lose electrons. On the right side, it tends to gain electrons. That's all I want to say about ions. Um, and we will come back to this when we learn about reactions. We will have another unit about reactions, and you will come to see that this reaction is called ionic reaction. It's called ionic bonding. But that's for later chapters. And for now, we have learned about how ions form and what requirements it needs to have based on electron shells. Remember the 2-8-8 structure. This is important. So I hope that was clear for everyone. And it can be confusing a little bit at first, but let's break it down into a couple questions so that you guys have a better sense. So, when an atom loses an electron, the ion formed is called, what is it, guys? If it loses an electron. Yes, I heard B, cation. That is correct. Yeah, that's right. When it loses an electron, it forms a cation. Let's look at this question, number 2. An atom, this X atom, forms bond by losing one electron. So the charge of an ion formed is, what happens when it loses one electron? It will have a positive charge, right? Yes, it's a positive charge. Yes, I heard positive 1. That's correct. It's C, positive 1, because it lost one electron. It has a positive 1 charge. That's right. So now let's look at this last question, and this will be the end of today's class after answer this one. So the chemical formula of an aluminum sulfide is AlYS3. So what is Y? So this question is a little tricky. First, we need to know what sulfur's structure is. Sulfur has an electron shell of 286. We can confirm that. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. On the third shell, 1, 2, 3, 4, 5, 6. Now sulfur wants to have 288 structure, so we need to add 2 electrons. 2 electrons. So it forms a sulfide ion of S2 minus. Did that make sense for everyone? Why it is S2 minus an ion? So sulfur's atomic number is 16. Here, I can show you the periodic table. Where is sulfur? Sulfur is here. Sulfur is over here. Can everyone see it? And the atomic number is 16. Sulfur's atomic number is 16. That means in the outermost shell, it has 2, 8. 2, 8 is fine. Sulfur holds 2, 8. But after you subtract 16 minus 2 minus 8, how many is left? There is 6 left, right? And that is the number of electrons in the outermost shell. That is why sulfur has a 288, 286 structure. And let's look at aluminum on the other hand. So where is aluminum? Let's take a look. Aluminum is over here. It has atomic number of 13, which is also the number of electrons, right? So the number of electrons in aluminum is 13. Let's go back. Aluminum has 13 electrons. Sulfur had 16. If we put it in order of 288, we can fill out 2 and 8. How many electrons are remaining? It's 3, right? So aluminum has 2, 8, 3 structure. It'll be optimal for aluminum to lose 3 electrons to become stable. What did it mean to mean stable again? Stable means having 8 electrons in the outermost shell. If we take away the 3, aluminum will have 8 electrons in the outermost shell. That's why it wants to lose 3 electrons. So now let's go back to ALY as 3. It requires 3 sulfide ion. That means the charge will be -6, right? Since -2 times 3 equals -6. But this compound has 0 charge. We want -6 to be 0. But how do we do that? We know that aluminum ion is Al3 plus, positive 3. So positive 3 times which number? Let's call it x. Sorry. The problem said y. How many atoms, ions of aluminum does it need to have to equal this remaining number? So it must equal 6 in order to balance this to be 0. Finally, y must be 2, right? If there is 2 aluminum ions, what will be the charge? 2 times 3 equals positive 6. There will be positive 6 for aluminum. But we know that there are three sulfide ions. So again, negative 2 times 3 equals -6. Sulfur has -6 charge. -6 plus 6 equals 0, right? So it balances out. And this was a really long and difficult question, but all you need to know is that in the periodic table, the atomic number equals the proton number and electron number. That is very important. From there, you can find the electron shell number in a structure of two, um, optimally 288. When an atom is not in this structure, you need to make the outermost shells equal to 8. Or the exception is, well, if it only has one shell, you make it into 2. But if it has 8 electrons on the outside, the atom is stable. So that is what we learned today. And yeah, thank you everyone for listening. And today was a little long lecture, but do any of you have questions about anything for today? So any questions about any topic? Maybe something confusing or so everyone have a question? Um, just feel free to ask me right now, or if you don't, it's also fine. Um, do you think today's lesson was a little difficult, or how did you guys think of today's lesson? Yeah, I hope it wasn't too difficult, but if it was, you can rewatch my video that I'll post. So if anything confusing comes up, and if you don't understand something from the slides, I will share this video, recorded video, and you can rewatch it. And I will maybe make a recap of today's lesson for next week too. But next week's topic is about filtration and other science instrument. So it'll be more of applied chemistry. So yeah, that's it for today's lesson. If you guys don't have any questions, I will see everyone next week then.
No.
All right, yeah. If there are no questions, um, yeah, I'll see everyone next week. Yeah, bye
All right.
everyone.
Okay, do it.
Yeah,
Bye bye.
bye everyone.
Bye, baby. I'll come in.